equations, and the goal of these is always going to be to figure out what the value of the variable is. So you might start off with a question like 75 plus something equals 133. And these are called one-step equations because it's going to take one step to solve them. So I think of this equal sign as like a balance from science class, where this side is going to weigh the same amount as this side. So my goal here is to solve for the variable. I want to figure out what is the value of this x. 75 plus some number that we don't know what it is yet is going to be equal to 133. So in order to figure that out, I got to get this extra 75 off of this side of the balance. And this is a positive 75, so I have to do the opposite of that, which would be a negative 75 would get rid of that 75. And so that's going to make nothing. That's gone now. So I'm going to bring down this x, because that's all that's left on this side. But because it's equal, if I just took like 75 pounds off of one side of the scale, it wouldn't be balanced. So I have to do the same thing to the other side. Again, to keep it equal, you have to do the exact same thing on both sides. So then I would have 13 minus 5 is going to give me 8. 12 minus 7 is going to be 5. So x is going to equal 58. The way to check that is if I think x equals 58, I'll substitute 58 in for x. 75 plus 58, I'm putting it in the spot of that x. 75 plus what I think is 58. It's going to make 13. That's 8, and 5 makes 13. 133. Yes, it checks out. The solution is what this is called, is x equals 58. Okay, next kind of problem you might have, maybe it would be something along the lines of so something, when I take away 17, I get 142. Again, this side has to be balanced out to the other side. They have to be equal, they have to be the same. So I have to get rid of this negative 17, this minus 17. So how you get rid of a negative 17 is you add 17. A negative 17 and a positive 17 make nothing. So then here I'm going to also have a positive 17, because I have to do the same thing to keep it equal, to keep those sides of the equation balanced. That x is going to be brought down. 9, 5. So it's 159 is what x is equal to. Again, how I can check that, I substitute in 159 for x. Since they're equal, I can put them in the place of each other. 159 minus 17 is 142, which is what I want it to equal, so it checks out. So really, if it's kind of like an adding one, I'm probably going to be subtracting. When it was a negative 17, I have to put a positive 17. And then, the pattern's going to follow. You're always going to be doing the opposite. So if I had something like that, this says 7 times something is going to get me to 161. Well, in order to solve this, I'm missing part of the multiplication problem. I don't know part of a multiplication problem. When you don't know part of a multiplication problem, you can do division. Or I can think of it as, I want to get this x by itself. So if I have 7x, which would be x plus 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 x, I would divide it into 7 groups. 7x divided by 7 is going to leave me with just 1x in each group. Well, if I divide this side by 7, in order to keep it balanced, I have to divide this side by 7. 161 divided by 7 gets me 23. And how I could check that would be to say, okay, 23 times 7. 7 times 3 is 21. 14, 15, 16, 161, it checks out. You have a multiplication problem, I'm missing part of it, I do the opposite, which is dividing there. I divide it to figure out the missing piece. Two more styles. One would be, if we had something like so I had something like this. 4/5 of something is 12. 4/5 of something is 12. So part of something is going to be 12. So that tells me right away I know this number has to be bigger than 12 because this is saying I have a fraction of something to give me 12. So in order to get rid of this is a multiplication problem, so I have to do the opposite, which is divide. Now, so I can divide by 4/5. 4/5 divided by 4/5 is 1. Okay. So that's going to bring down the x. But then when I do 12 divided by 4/5, that one might be a little bit more challenging. If you know 4/5 as a decimal, you could change it to that. That would be okay, and you could do the division there. But when we divide with a fraction, 12 divided by 4/5, if I can't divide across, I'm going to multiply by that reciprocal, or the phrase that we've used is keep, change, flip, but that's flipping that second one is the reciprocal. Dividing by 4/5 is equal to multiplying by the reciprocal. So then I would try and simplify here. 3 times 5 is going to make 15. So x is going to equal 15. If I reworked it out, then 4/5 times 15 over 1, 4 times 3 is 12. 5 went into 5 once, 5 went into 15 3 times. That's where that came from. 4 times 3 makes 12. Last one I want to look at is a division problem. So if we have x divided by 7.3 equals 20. That's saying something, when I take it and divide it by 7 3/10, I'm going to get 20. Well, again, I got a division problem. If I'm missing part of the division problem, let's multiply the numbers so then we can figure out what we have. So I'm doing the opposite of multiplying or dividing by 7.3 is multiplying by 7 3/10. But if I do something to one side to keep it equal, I have to do it to the other side. And 20 times 7.3, well, we'll work that out. 7 3/10 times 20, the 0 is just going to be there. That's 6 and 14. We have one decimal place. So x is going to equal 146. I could plug it in. 146 divided by 7 3/10 should get me 20. Checks out.